Parkinson's disease is a debilitating neurodegenerative disorder that affects an estimated 7 to 10 million people worldwide. PD patients may suffer from shaking, rigidity, bradykinesia, difficulty with walking, and other motor symptoms. The current diagnosis methods often need to be administered by trained healthcare professionals in clinical settings and require extra efforts from patients to perform the tests, presenting a hurdle for large-scale screening and early detection. Accessible, longitudinal, and self-administered PD screening methods are needed in order to provide early diagnosis for more efficient treatments to manage PD symptoms. Handwriting has been identified in various researches as a useful marker of PD symptoms. However, limited studies were conducted on Chinese words. Leveraging on this, the project presents an end-to-end Parkinson risk detection mechanism based on users' handwritten Chinese characters. A video demo will be played to showcase the functionality of the application. Users will be greeted with a welcome page when they open the app, with their current progress shown on the right of the screen. At the Options menu, users can choose to start writing or view their historical writings. To start, select Start Writing and users can preview the verse, or shuffle to change to a different poem. Click Start to enter the writing page. Here, the chosen poem is displayed with the word to be written in the middle of the screen. Users can choose to erase or go to the next word when completed. During writing, the trajectory information is stored as pixel arrays associated with timing data. Intelligent character recognition is also implemented here to check for the written word. A wrong word will prompt an error message, and only 3 tries are allowed for each word. The number of attempts and whether a word is correctly written are stored as additional information in the background as well. When completed, users can then navigate to the gallery page, select the poem marked in green, and view their historical writings. A high-level view of the data format is shown here, with the fields that are stored. Every intermittent screen capture will return a 64 x 64 pixel array representing a single channel image, with 1 denoting an ink event and 0 denoting an empty pixel. For example, for the word Hong, the line corresponding to it will look like this. With the collected data, the next step is to build a machine learning model for distinguishing the handwriting by healthy users versus PD patients. Since motor symptoms such as micrographia are closely related to temporal changes, we propose to use a hybrid convolutional neural network plus long short-term memory model for visual time series analytics. The proposed model comprises 2 stacked submodels. CNN with max pooling layers will act as the preprocessing layer for image compression, noise reduction and feature extraction. LSTM handles the sequence modeling part and makes predictions based on the hidden sequential patterns learned in the handwritings. As a proof of concept, a preliminary objective is to have a model to differentiate handwriting between younger and older adults. 3 different models with different hidden layers were built with the following input and output configurations. Since it is a binary classification problem, the loss function used is the binary cross entropy. The best model out of the 3 contains 1 CNN layer with 20 feature maps and a L2 regularization of 0.01 to reduce overfitting. This is followed by a max pooling layer of 3 x 3 window. Both layers used valid padding so as to reduce the dimension of the images. The output of the pooling layer is flattened into vectors which were passed into the LSTM layer with 20 time steps. Here, a dropout of 0.2 is applied to counter overfitting as well. Its output is passed through the dense layer with 1 neuron output for binary classification. Due to the small sample size, the model was trained over only 10 epochs. 500 writing samples were taken from 5 adults below 30 years old and another 5 above 60 years old. Each of them were tasked to write an identical set of Chinese characters. From the best model, an accuracy of 70.8% is achieved with a recall of 64% and precision of 76.2% for younger handwriting. These values can be improved with more samples. To scale the system in the future, federated learning can be adopted to perform decentralized machine learning, where user data is being trained on the device, and only model parameters are shared on the server. Not only will this enable scalability, but it also ensures data protection and privacy which will align with legislation. The detection system can be embedded in mobile phone's handwriting keyboard, which will collect and analyze handwriting patterns unobtrusively. If a user is suspected to show early symptoms or have a high risk, a warning will be issued to them, facilitating early detection. The proposed handwriting-based PD screening system offers a standardized and accessible method of population-level PD early detection that can dissolve into everyday use, holding significant potential as the world population ages.